My name is Kenny Ham, and welcome to America, home of the electronic convenience. For me, there's nothing better than sitting back and watching the newest DVD release on my giant screen TV. No wait, yes there is. So I must admit, there's nothing like watching the newest DVD release, a bag of fresh microwave popcorn, and you guessed it, a bottle of ice-cold root beer. For me, it just doesn't get any better than this. Which begs the question, where would I be out if the power goes out? Such a slight problem. Not only was the fridge keeping my root beer ice cold, it was keeping my chow mein from becoming chow mush. And unless I get the power on before tomorrow morning, all my groceries are going to be so much rotten garbage. Additionally, this being the middle of winter, my supposed gas heater, which actually runs via an electronic blower fan, has shut down and the house is starting to freeze. So, wouldn't it be great that if when the power goes out, our electronic necessities stayed on? I guess. Alright, so seeing how it would be advantageous to have a backup power supply for electronic necessities in the American household, the first and obvious question is, why not get a gasoline generator? Well, the answer is twofold. The first is maintenance, because with a gasoline generator, you have to make sure the fuel's fresh, you need to make sure the oil's topped off, the air filter's clean, and the spark plug's not fouled, along with a couple other factors. Failure to keep up on any one of these maintenance factors means the unit's not going to start when you most need it in the middle of a blackout. Now, the second and more considerable aspect of a gasoline generator is its cost. Because quite simply, a gasoline generator runs on gasoline, and a lot of it at that. And I'm sure you've been to the gas pump recently, and you've seen how expensive this stuff is getting.
Another reason that a gasoline generator is not an ideal backup power solution is because during severe weather events, such as a blizzard or thunderstorm, you would have to go outside and manually turn on the generator, which is not an enlightening prospect if you're in the middle of a thunder and lightning storm, or for below freezing weather. Additionally, most severe weather has cloud coverage, which means that a solar-based backup solution would also not be very practical. The ideal solution, therefore, is a wind turbine, because one thing severe weather does not lack is plenty of wind power.
Seeing as how a windmill is the ideal backup power solution for a typical household, the question then becomes whether a vertical axis windmill or a horizontal axis windmill is better suited. Now, if you're unfamiliar with the difference, a horizontal axis windmill is your traditional fan blade style windmill that of course spins about a horizontal axis. Whereas on the other hand, a vertical axis windmill is more your disc-shaped variety that spins about its vertical axis. So, while the horizontal axis windmill may be more popular, there's two reasons that prevent it from being the most ideal solution for a household. The first is installation, because in order to get enough clearance for the long blades of a horizontal axis windmill, they typically have to be installed on top of a tower or pole, which adds significant time and cost to their installation. The second is aesthetics, because being box fan looking, your horizontal axis windmill is of course usually no more attractive than mounting a large box fan on your roof. And in fact, several homeowners associations will prohibit their installation because of this. Now, on the other hand, a vertical axis windmill offers ease of installation because it can be bolted directly to the top of a roof. And, as you can see, they offer a better range of aesthetical options. So, seeing as how a vertical axis wind turbine is the better option for mounting on a household, it should be noted that there's still one design characteristic of them that prevents them from being as efficient as a comparably sized horizontal axis wind turbine. This inefficiency, called counter torque, occurs because when a vertical axis wind turbine enters the wind stream, there is airflow hitting the front side of it, which of course produces torque in the direction we want to rotate. However, there's also airflow hitting the back side of it, which is creating a counter torque and thereby lowering the overall output of the wind turbine. To be precise, my model here, which is currently spinning at 70 RPM, is only putting out about 2/3 of what a comparably sized horizontal axis wind turbine could be doing at these same wind speeds. So this is where the unique aspect of my windmill design enters the picture. This is the revolving shroud. Now, as you can see, it looks like a half moon shaped with a rudder on it. Quite simply what it does is it installs on top of a standard vertical axis wind turbine, and it uses the rudder to keep it in line with the wind so that it will effectively block the airflow on the backside of the wind turbine, thereby effectively removing the counter torque effect. So, how much does the shroud help? Well, if you remember, my wind turbine here, which was previously spinning at 70 RPM, is now spinning at 130 RPM. Quite a significant gain. In fact, it's enough of a gain to make it just as efficient, if not more efficient, than a comparably sized horizontal axis wind turbine. So, because this design is more reliable than a generator and more likely to work during severe weather than a solar panel, and of course easier to install and more aesthetic than a horizontal axis wind turbine, I conclude that this vertical axis wind turbine with revolving shroud is the ideal backup power solution for a typical household.